In this video, we're going to look at using two triangles along with our trigonometry to solve some problems. You do need a calculator for this video, so if you don't have yours handy, go ahead and pause the video right now so that you can dig yours out of your backpack. You also need to pause the video and just read through the very first question so that you can familiarize yourself what's going on in the problem. Okay, so at this point, hopefully everybody has their calculator. Hopefully everybody's read through the first problem and we understand what it is that we're trying to find. Maybe even are familiar with a little bit about what's going on in that question. I noticed that the question is asking us to find the distance from the roof to the windowsill. So in the picture, that distance is represented by that little red line segment. That's going to be the first thing that I'm going to take or pay attention to. For both of these questions that we're going to look at today, we're going to take a look at two triangles. Most of the diagrams will have more than two triangles as part of the picture. We want the two triangles that involve the right angles. So that said, in this picture, the two triangles that involve the right angles are going to be the triangle represented by the blue line segments and the triangle represented by the green line segments. And I'm going to start by drawing those triangles outside of the picture so that I don't get confused by all the little pretty trees and the firefighters and the buildings and everything that has kind of gone into and cluttered up that picture. So I want to simplify these triangles as much as I possibly can. I know that in my blue triangle, that angle down near the horizontal is 40 degrees. I know that that horizontal distance is 72 feet. And similarly for the green triangle, I know that the angle down near the base of the triangle is 32 degrees, and I know that the horizontal distance is also 72 feet. I don't know the vertical height of the blue triangle, nor do I know the vertical height of the green triangle. If I knew both, I would just subtract the green height from the blue height, and I would be good to go. So I'm going to let the height of the blue triangle be x, and I'm going to let the height of the green triangle be y. And I'm going to see if I can use some of my trig functions in order to solve for x and to solve for y. In the blue triangle, x represents the leg opposite the 42 degrees. 72 represents the leg adjacent. So I want to use the trig ratio that deals with tangent. And if you take a quick look at the green triangle, you notice that the same is true. We've got the opposite side y and the adjacent leg 72. So I'm going to go ahead and set up my ratios for each of these two triangles. In the blue triangle, tangent of 40 degrees is equal to the leg opposite x over the leg adjacent, or 72. And when I cross multiply that proportion, I find that x is equal to 72 times the tangent of 40 degrees. And in a similar fashion, I can go ahead and set up the ratio for the green triangle. And when I cross multiply for the green triangle, I find that y is equal to 72 times the tangent of 32 degrees. I know that the piece that I'm looking for, I'm going to call it d for distance. I know that that d for distance is the difference between the height of the blue triangle and the height of the green one. So my d value is going to equal x subtract y. Well, substituting x into the equation, x is 72 times the tangent of 40 degrees, and y is 72 times the tangent of 32 degrees. And at this point, I'm getting ready to go ahead and to substitute everything into the calculator. I'm going to pay attention to my digits. They want us to round our answer to the nearest tenth of a foot. So since this is a rounded answer, I'm going to use my squiggly equal sign to indicate is approximately. And this is where I'm going to go to my calculator. And I'm going to type in 72 times the tangent of 40 degrees. And from that, I want to subtract 72 times the tangent of 32 degrees. And I want to make sure that I round my answer to the nearest tenth. So to the nearest tenth, that's going to round to 15.4. And I do believe those dimensions were given to us in feet. And that seems reasonable to me. It's not ridiculous, it's not outrageous. That answer seems reasonable. You always want to double check and make sure that your answer seems logical, sounds reasonable for what it is that you're trying to find. 15.4 feet from the top of the building down to a window seems reasonable and logical. All right, so there's the first of our two examples that we're going to take a look at. The second one is similar in some ways, but different in others. I want you to once again pause the video, take a minute so that you can read through the problem and familiarize yourself with exactly what's going on in this particular question. Okay, so in this question, I'm going to begin exactly the same way as I did with the other one. I'm going to begin by taking a look at the two right triangles. So in this case, the first of the right triangles is that purple one. The second of the right triangles is that blue one. And just as I did in the first example, I'm going to take those two questions and I'm going to remove them from all the clutter that's going on, or those two triangles, and remove them from all the clutter that's going on in the problem, just so that I can isolate the pieces that are really truly important. So in the purple triangle, this horizontal distance down here is x, the angle is 40, and we've got this h, which represents the height. And in the blue triangle, we've got, again, the h for height. The horizontal distance will be all of the x in addition to the 20, so x plus 20. And that angle down at the base of the triangle, 30 degrees. So like the first problem, this question also deals with the tangent ratio. So tangent, remember, is the comparison between the leg opposite and the leg adjacent. So for the purple triangle, the tangent of 40 degrees is equal to h over x. And again, just like I did in the first problem, I'm going to go ahead and I'm going to cross multiply. So h is equal to x times the tangent of 40 degrees. In the blue triangle, same idea. I'm going to go ahead and set up that ratio. Tangent of 30 degrees is equal to the opposite leg, so h over the adjacent leg, x plus 20. And again, I'm going to go ahead and cross multiply. H is equal to tangent of 30 times, and I want to multiply by that whole leg. That whole leg is x plus 20. So it's important that I wrap parentheses around that to indicate that I'm multiplying by the length of that whole leg. And at this point, we've reached kind of a stumbling block because unlike the first example where we only had one variable, in this example, we have two variables. We've got an h and we've got an x. In this equation, an h and an x. So this brings us back to systems of equations, which you looked at during your 8th grade math class and during your algebra math class. Both of these are equal to h. Since they're both equal to h, I know that they must be also equal to one another. So I'm going to go ahead and I'm going to set these equations equal to one another. So tangent of 30 times the quantity x plus 20 is equal to x times the tangent of 40. You could have written those on either side of the equal sign. I kind of have the advantage of knowing what's coming, and I wanted to make this the one in which I'm going to need to distribute on the left side just to give me a little bit more room to work with. Because distribute is what I'm going to go and I'm going to do next. So I'm going to go ahead and distribute the tangent of 30 degrees to each of the terms that are inside the parentheses. So this becomes x times the tangent of 30 degrees plus 20 times the tangent of 30 degrees equals x times the tangent of 40. And at this point, I'm going to add or subtract all of the terms that have an x in them so that I can get all of the terms with an x in them on one side of the equation. So I'm going to go ahead and I'm going to subtract x times the tangent of 30 degrees from the left side and subtract x times the tangent of 30 degrees from the right side. When I do that, I get 20 times the tangent of 30 degrees on the left side, And on the right side, I've got the difference of those two terms. So x times the tangent of 40, subtract x times the tangent of 30. Both of the terms on the right side have an x in them. That's important because now I can go ahead and I can factor out the x. So this becomes x times tangent of 40 degrees, subtract tangent of 30 degrees. And on the left side, I'm still working with that 20 times the tangent of 30 degrees. The factoring was really useful because now I can simply isolate the x by dividing both sides by the tangent of 40, subtract tangent of 30. And on the right side, what remains is an x. On the left side, what I've got is 20 times the tangent of 30 degrees for a numerator, and tangent of 40 degrees subtract tangent of 30 degrees for the denominator. And you might be breathing a huge sigh of relief right now because you're thinking that, okay, all we need to do now is plug that into the calculator and we're done. But unfortunately, there's a little bit more to it. In this question, they're asking us to find the height of the building. The height of the building is represented in our picture by the variable h. So in other words, they're asking us to find h. We've solved for x. Now before there's any despair, I'm just going to go back and remind you that we started out with these two equations that we set equal to one another. Both of the equations are equal to h. We can find h simply by taking x and multiplying it by the tangent of 40, or we can find h by multiplying the tangent of 30 by the sum of x plus 20. You can use either one of those two equations to go find h. I'm going to use the first because I think it looks a little bit simpler to work with. So this says to find h, go multiply x. So I'm going to substitute in that big fraction in place of the x. And I want to multiply that times the tangent of 40 degrees. And so finally now I'm ready to go ahead and I'm ready to use my calculator. We want to find h. Unfortunately in this problem it isn't indicated to us what exactly it is they want us to round to. In an assessment they will always tell you what to round to. In this particular case I'm going to say let's round the height of that building to the nearest meter. So I'm going to go ahead and I'm going to put these into the calculator and I'm going to round to the nearest meter. In this denominator here, I have to go back and take a peek. Tangent of 40 minus tangent of 30. And then I want to multiply that fraction times the tangent of 40 degrees. So to the nearest meter, the height of this building, 37 meters. Phew. That was a good one. That definitely made me think. As always, I want to say I'm thankful for the gift of your time. I do want you to take a few minutes, capture, summarize in your own words the key ideas and the important takeaways that you have from this video. And then I think in the interest of time, since I went a little bit longer than I like to go with these videos, I think we'll only have you take a look at number 2 and we'll save number 3 for when you come back to class. So this one we'll save for class. And again, as always, my deepest appreciation for the gift of your time.